So I know, having introduced this and put one view of this, I would now like to ask Pei Wang to give his talk. Pei, are you ready? You're still writing it. So this is what you want.
Oh, yes.
This, and then, you know, what do you press on this? What is it?
Switch.
How do you switch to the other one? Here we are. Switch. You see? Switch. Exit this little one. And then constructor on top.
Okay, wonderful. Thank you. And then full screen.
Where?
What if you press escape? And then view. Full screen. Slideshow.
Go to the slideshow. And you switch it over.
Click on it.
It's
Oh, no. And then slideshow, you can see it's too small. Slideshow here. And then,
and without an instructor.
yeah.
It's like to the top one. Try that. There it is.
Okay, wonderful.
There you go.
All right. We all know that in recent years, deep learning achieved very good success. Very impressive. That's not a problem. Now the question is whether it can lead us to AGI. It's a difficult problem because, as Leslie just mentioned, both concepts in this discussion are not well defined at all. Deep learning comes in a large number of different shapes and forms. It's not one single technique. Furthermore, we have quite different understanding about what AGI is. So in this talk, I will only talk about a typical form of deep learning. So I'm not making any claim of all possibilities. But on the other hand, of course, we cannot go too far to say, everything can be interpreted as deep learning. Then we cannot really use this concept meaningfully. So I think this simplification can be justified. For the same reason, I'm going to use a relatively vague notion of AGI, which probably does not capture everyone's understanding about that concept. But again, we have to start somewhere. So what I mean by AGI in this discussion, I think I'm trying to find the minimum or the maximum consensus in this community. I think at least we all, or almost all, agree that we are talking about general purpose system, not a system that can only do one thing. And also, at least most of us, I think, in this community take the approach or the opinion that intelligence should be taken as a complete or whole thing, okay, rather than cut into pieces like what the mainstream AI has been doing. And finally, I think at least many people will agree that we are talking about systems that can work in realistic environments, not something that work in highly idealized or very special situations. Okay. That's what I'm going to assume for AGI in the following discussion. And on the other hand, what is deep learning? Again, as I said, we're going to take a very general form. Start from the concept of machine learning, which this is from a recent textbook. I think they did a very good job to summarize the most common understanding of machine learning. Is we want to carry out some kind of task, which is, mathematically speaking, is a mapping from the input to output. But we don't have the formula or algorithm to carry that out. So instead, we use a learning mechanism, which in a sense is a meta computation or algorithm, which takes some training data and produce a model as an output, and then we're going to use that model as an algorithm to map to solve the domain problem. Okay, that is a quite general concept about the kind of like the most typical form of machine learning in today. Again, it doesn't cover all possibilities, but that's the form I'm talking about. So that's machine learning in a very general form. And then here, what we are assuming, or what the learning people have been assuming in this picture, is first they try to they basically assume without argument that learning can be isolated from other functions, can be studied by itself in this form. And learning can be defined as a function approximation. Okay, from some given sample data, you generalize them into a general situation. And the learning can be carried out by algorithm. So whenever you talk about learning, people will typically ask you what learning algorithm you're using there, assuming that you don't need to mention that it has to be some kind of algorithm. So what deep learning add into this picture? What I said is just machine learning in general. Well, I think, again, we're going to talk about the typical form. One is what is deep or stress, that is a multiple level of generalization, not just one level or two levels. Then typically is structured is artificial neural network, even though of course that's not the only form of deep learning, I know that, but this is the most popular form. And then combine this together, generalization will be carried out as a vector mapping from layer to layer in the most typical form of machine learning system or deep learning system. And this generalization or this mapping is many to one, so that's generalization. So you map many different things into the same thing as a vector in each level. And then what is very remarkable compared to the traditional way of learning, people have stressed that we're doing representation learning, that is intermediate representation, and not designed into the system, but learned by the system itself, meaning that it's structured and selected among candidates according to training data. Okay. That's my picture about what deep learning contributes if we, without going into technical details, okay, into the machine learning structure. So again, this is a type of a typical form, again, not the only form of deep learning, with of course many, now more and more intermediate layer in between. So if we compare this with the thing I said at the very beginning about what AGI requires, what are the issues? At least I'm going to talk about the issues again from the three aspects. One is whether it's general enough. The second one is whether it can actually capture all forms of functions needed for intelligence. And finally, whether it can work in a realistic environment. The general issue, I think, be very careful when we talk about general. Many people say, yeah, machine learning is general because the machine learning algorithm, including deep learning algorithm, can be applied in many domains. Yes, of course, that's true, but that's not what general means in the context of AGI. Okay, if that is what general means, we can say almost every AI technology is general purpose because it can be used in different domains. Okay, in AGI, what we suggest is, for example, the representation capability, expressing power, can be naturally used to represent all types or almost all types of human knowledge. Okay? I think there is a big issue here, at least for me, because now deep learning structure typically forces you to use vector for everything. Use vector is pretty natural, of course, for perception. That is why I think that's a major reason why so far the deep learning success are typically in perceptions, in image processing and speech understanding and so on. Okay, where at least the input data naturally in the form of vector, it makes pretty natural sense. On the other hand, now they are beginning to use the same thing for natural language processing, for example, word vectors, and also more abstract domain, they use sort vectors and so on. To me, it's not that natural at all. Be careful, you see that I'm using the word naturally, I'm not talking about whether it is possible to represent something as a vector. Because in principle, okay, it is of course possible to represent everything as a vector. Because you can code everything as a binary string, which is a vector. But you cannot really argue in that way. Okay? It's just like in principle, every software can be represented as a string of their own ones, but you don't want to design your software in that manner. So to me, for example, now the current technology is to use a vector to represent a word or a concept, which to me is not very natural at all. It's not natural, it's not convenient. I don't know what the dimensions mean in that kind of representation, and I will make the processing highly limited. For example, so far what I can see is in that representation, they basically can make similarity judgment, which is of course possible. They say this word is similar to that one in terms of meaning, yeah. But if your representation can only support similarity judgment, I will say it's far away from what AGI expects. Okay, there are all kinds of similarity, and things are similar to each other for many different reasons. Okay, if you can only say similar to a degree, there are a lot of analysis you cannot really do at all. Okay. So that's one thing, and also if we talk in terms of cognitive science, I will say just use a vector as a representation for a concept. It's not an attractive idea at all. There are all kinds of limitations we can discuss later in detail. So I think one of the issues many people have raised is we see there's a big difficulty in transfer the knowledge learning in one domain to another in a neural network, and as well as interpret the intermediate process. There are well-known difficulties. To me, it's not just difficulties. There are limitations to a large extent that come from the fact that they stay with a vector representation. It doesn't give you enough support for semantics, for meaning, for anything related to that. So, and also go back to the big picture. I say that to treat all forms of learning altogether as function approximation itself, to me, I think it's a mistake. Okay? It's a very limited view of learning. If you again think psychology, think about cognitive science, that is a form of learning, but far from the only form of learning. Okay? Force everything else in that framework will lead to all kinds of troubles. So that's whether it's a general mechanism. The second one is we want a general intelligence, meaning that we want all types of intelligent functionalities. Now it's far from clear how that form of learning is related to other things like reasoning and planning. Recently, many people are trying to do that. For example, use deep learning framework to do reasoning. Since my own work is mostly in reasoning, I'm not impressed at all. They basically turn reasoning into some kind of mapping. Okay, that's far from what we call reasoning in general. Again, it's a big topic. I will just want to make my statement here. The same thing for planning and decision making and many other things. And also, I just already touched, learning comes in many different forms. It's not always or only generalized from given examples. Okay? Many learning, for example, learning comes from being told, like how to learn a concept of cat. Well, that's a success story of deep learning, right? What it does is you show it millions of pictures of cat, and it will generalize the concept of cat, which is wonderful, but it's far from how human beings learn the concept of cat. That's only part of the story. Right? We also teach our children, a cat is a kind of animal which have this and that form. If that before that child even see a single cat, we can do that kind of thing, and that kind of knowledge helps. Okay? If we are forced to learn everything from concrete instance, very big trouble in many domains. And Gary Marcus also just mentioned that, which I fully agree. So this is a good thing, but it's only one form of learning. We should not take it as the only game, okay, in the top. And also another thing I have a big problem is the separation of a learning process and a working process. As I have already shown, that's not the problem limited to deep learning, that's for machine learning in general. They basically say that you train the model, and after you train the model, you begin to use the model to solve problems. In human mind, it's never so clearly cut. We learn when we are working. Okay, so I'm fully supportive of the concept of lifelong learning because, well, that's what happened to us. It should not be such a clear separation, even though relatively speaking, yes, when we were young, we learned, spend most of the time for learning, even though we are also solving problems at the same time. We're getting older, we're not, full-time learner anymore, but we are still learning from our working experience. So I don't see the argument which you have to clearly separate these two phrases from each other. And also, this is a big claim, I know. To me, learning is not an algorithm following process. You don't really have a learning algorithm if you think about human beings. Instead, you have many teeny tiny algorithms which interact with each other, which give you the learning process or experience. So again, no time for the detailed discussion, but that's why I'm not satisfied with deep learning with respect to those issues. Finally, many people say, yeah, deep learning is realistic because they have already solved many practical applications, which I fully agree. But on the other hand, there are some restrictions which has not been taken fully into account. One is small data. Okay, what if you only have one instance? Can you learn anything meaningful from it? Okay, several people have already touched that. And also human learning, where I'm not saying big data is bad. Okay? I just say that big learning is not absolutely necessary for learning. And instead, we basically learn from whatever we know. And we build on that, we incrementally improve the results. Okay? We don't demand big data from the very beginning. Lifelong learning, I already mentioned. Real-time response, which is typically completely ignored by deep learning. And what we need is some type of anytime algorithm, as you can guess what I'm suggesting. And also to achieve real-time response, one thing we do is we selectively use our knowledge. Okay? We don't, whenever we see a new instance, we change all the parameters in the system, which is just practically impossible if you are talking about large-scale system. And also you want to perform in real time. That's impossible. You have to. It just recently the concept of attention begin to get attention of the machine learning people. But to me, that should be taken into consideration from day one. Okay? You don't have the resource to think about everything. So that's basically it. Okay? There is a summary of what I think is good, what I think is bad. So in general, I would say, I'm not saying deep learning is a complete failure, of course not. It's a good thing. We can learn a lot from it, but it does not solve the AGI problem for the reason I just mentioned. That's it.